Hi YouTubers. I'm measuring or first approximation of capacitance in a supercap. So I'm starting at 2 points, what was it, initial beginning voltage 2.170. I'm going to cut off, okay, down there on the bottom is when I was charging it up. So I'm going to get ready now to discharge it. Let's see. Okay, let's say 2.674. Now, I freshly charged this supercap up. It's a SAM NHA green cap EDLC DB. 2.7 volts, 100 farad is claimed, the latter as the capacitance on this supercap. I've had it about 3 years. Haven't been using it much. Okay, so right now we're at 2.67. And it's losing some potential. But this is just an approximation to show you with my students how I get them up and running with farad determination. I'm using the familiar EB tester put out by ZBTech. I have a whole bunch in the lab here, you can see. And I have very, very good success with them. I like them very much. Okay, so what we're going to do, we're going to start at 266, test amperage of a quarter of an amp. Cutoff would be 1.688. Let's start. And we're going to time this and see how long it takes to get down to, let's say, 1.69, measuring in seconds. I don't have a timer, but you could see it up here. 13, 14, 15 seconds, right? This is a very handy device. I get them on Amazon. Been using them for years. So we're going to take this down to 1.69 volts. And we'll determine the time interval. More about that in a minute. I'm doing this with one hand, but okay, so far capacity is 3 milliamp hours, energy 8 milliwatt hours. You can get the average voltage if you've not used one of these. We're at 2.447 volts at the quarter of an amp. And I'm not drawing more current right now because this is an initial approximation. I'll have my students do this 10, 20 times, use Excel to do standard deviation, and also determine the first approximation of capacitance in farads with different inputs of voltage intervals. 2.34, so this will be running for a while, and so far a minute and 38 seconds. While we're waiting, let me go over to the whiteboard. I'll go over to the next lab. I'm in the chemistry department, University of Pittsburgh, Bradford campus, Northwestern Pennsylvania, USA. Here we have the equation, rather simple. Current is equal to capacitance with the derivative of voltage with respect to time. However, for practical first approximations, instead of derivative, we will use an interval. So if I'm using 1 volt difference, let's say here on the whiteboard, going from 2.0 volts down to 1.0 volts and then shut down, what I can do with the current being constant, which I'm doing with the device in the other room, you then have the interval of delta V over delta T. Measure that in seconds, plug in your 1.0 volt, rearrange, solve for capacitance first approximation in farads. There is internal resistance, of course, with supercaps. That's another study which I'll upload a video how to practically do it with them. Get an approximation with a multimeter and I'll upload that. But let's see where we're at right now. 2.05. So this will be running for quite a while. But as soon as I get down there to 1.69 volts, I will stop it, plug in the number of seconds, and get a farad determination. Now, this device is telling me it's got 100 farads. Let me say this. I did one quick and dirty approximation and got 90 farads. I don't have down the internal resistance, ESR, of the capacitor, supercap. But an approximation, a measurement should be made to take into account the effect of the fully charged supercap when it's being discharged. But anyway, you get the basic idea of what I'm doing with this. And we're down to 1.87 volts. You could see the familiar discharge curve for the supercap. In red is the constant current. And as soon as I get to 1.69, that's going to shut off. It's going to be, right now we're at 4 minutes, 20 seconds. It won't be much longer. Then you plug the seconds into that equation, solve for the farad. I hope this helps people getting up and running. Thanks for watching. I'll upload first approximation of internal resistance, ESR, it's called, in the supercap. Thanks for watching, guys. Bye for now.